I have my function, -2 times x minus 2 squared times x plus 2, and I wanted to pick which graph I have. I already have it written up here to make this video go a little faster. The first thing you want to decide is end behavior, and I would rather not have to multiply -2 times x minus 2 times x minus 2 times x plus 2 just to find out the leading term. So our shortcut to doing that is we take this -2, then x minus 2, that x is in the front, so that's that x, squared, so I write it twice. And then in this one, that x is in the front, so I've written it, and there's to the first power, so there's only one of those. If that was an 8x, that would be an 8x. Okay, but you just write what's in front of every factor and multiply them together. And -2 times x times x times x is -2x to the third. So without multiplying -2 times x minus 2, get an answer, times x minus 2, get an answer, times x plus 2, taking me all day, we've just got the leading term. Okay, now, this one here, it's odd. So if the degree is odd, now the leading coefficient is -2, the leading coefficient is negative. Odd means that your end behavior is 1 up, 1 down. But because it's negative, it means eventually as you move your eyes across the graph from left to right, it's going to be down. So by default, it had to start up. If this was a positive leading coefficient, your eyes would eventually go up, so it would have to start down. Quick review of your other ones. If your degree was even, they're either both up or both down, but even and positive both up, even and negative both down. But I know that odd, 1 up, 1 down, negative, so finishes down. So out of my graphs, starting up and finishing down, those are both down, no. Both up, no. 1 up, starting up, going down, this one was a possibility. This one both down, no. Up, down, this one was a possibility. And then starting down, going up, no. So that narrowed it down to these two, just the degree and the leading coefficient, so that I could figure out end behavior. Then after that, I need my x-intercepts. This one's a little bit easier for the x-intercepts because it's already factored for me. So since it's already factored, I'm technically setting each factor equal to 0. If you set -2 equal to 0, that's nonsense. -2 is never 0. X minus 2 equals 0 leads me to 2. And x plus 2 equal to 0 leads me to -2. I have x-intercepts at both 2 and -2. And that would have been enough in this multiple choice question to get my answer, because this one has a x-intercept at -2 and at +2, and this one has 3 different x-intercepts, so it's not it. So I could have already figured out it was this one, but taking it just a little bit further is the behavior at the x-intercept. X minus 2 is to the second power, so technically I set x minus 2 equal to 0 twice, so I got the answer 2 twice. So this number has multiplicity 2. But x plus 2 is to the first power, so setting x plus 2 equal to 0, I only did that once, leading me to -2, so its multiplicity is 1. And when you have an even multiplicity, then you're going to bounce off the x-axis at this number. And if you have an odd multiplicity, you're going to slice through the x-axis at this number. So in this one here, notice at 2, I bounced off of the x-axis. And at -2, the graph sliced through it. Further, like pieces that I could use to like eliminate graphs is the maximum number of turns that a graph can have is the degree of the polynomial, which was 3, minus 1. So the maximum number of turns is 2. Doesn't mean for sure you have 2, but you have at most 2. And notice this particular one has 1 turn, 2 turns, and we have the maximum number of turns, so that works out as well.